All right, we're going to go through question number 6 from the 2019 exam. Here you are presented with a histogram of the prices of rent for a month for a one-bedroom apartment from a specific website for a specific city. Part A simply says to describe the population for which it's appropriate to generalize the results. The distribution of the 50 rental prices of the available apartments is shown in the following histogram. So here, obviously, we're describing the distribution. So I'm thinking about shape, center, spread, anything that's unusual. I don't have the original data set here. So going deeper and trying to calculate medians or means, you can do some of those rough estimations, but I'm not sure exactly what the original prices are. So calculating those are really probably not what the question writers were intending for you to do. What we are expecting you to do is to give me some general notations. So for example, the first thing I notice is that there's a very skewed right graph here, where you have the chunk of your data is down in the lower 2,000 range, or anywhere from 2,000 to 3,000, and then you have this pretty big tail that goes off to the right side. So I said the distribution of apartments is very skewed right, ranging from about 1,600 all the way up to 5,200. The typical or median price of the rental for a one-bedroom apartment is approximately 2,600. Now you see I've numbered the tops of these histograms to try and estimate where the median value falls, right? We know there's 50 people, so wherever I find the 25th person is where that median value is going to fall. Now these are going up by 200, so 16, 18, 2,000, and so forth. So if you count this, 2, 3, 9, oh, I missed one. Did I get that wrong? No, I'm good. So that's 3. When you add it all up, basically you get to 25 in this section right here. So approximately somewhere in the neighborhood of 2,600 is where you're going to find your center. I used median here because that was, number one, the easiest thing to calculate. Number two, I have a skewed graph. Giving the mean here would probably give a very much inflated result for center. Probably giving you a mean somewhere higher than 3,000, so that wouldn't really be an appropriate measure of where the majority or typical prices would fall. Now, interestingly enough, in part B, it kind of addresses this specific fact. Emma wants to estimate the typical rental price for a one-bedroom apartment in the city based on the distribution shown. What's an disadvantage of using the mean rather than the median as an estimate of the rental price? Now, be careful. It's specifically asking why is the mean a bad thing, right? So keep in mind, I need to make sure to mention that. Giving the contrast of why the median is a better choice is also a good thing to add to the mix to try to give us compare and contrast result. So I said the mean would be influenced by values to the right of the chart. It would give an inflated estimate for the typical rent price. The median is a much more representative value for rent as it resists extreme values on the high end. Right, basically, I'm just saying here that because of the shape here, the mean is going to be pulled a little bit higher and it won't be representative. The median value resists these really, really high-end values, and it's going to stay more clustered where that peak is falling, somewhere around the mid-2000s. Part C tells you to say, kind of goes in and it says, instead of using the sample median, we're going to be using the mean, we're going to be using the median values. Okay. Instead of using the sample median as the point estimate for the population median, Emma wants to use an interval estimate. However, in order to do that, we would have to have a lot more samples, but we don't have them, right? So they want you to describe a method for getting sample sizes of 50, creating a sampling distribution. Remember, this is where you take lots of samples and you calculate the mean or the median for that single sample, and you get the one number to represent those 50 individuals. All right, this is what would generate your normal models and all that kind of stuff. So in order to do that, theoretically, how would I do this for all possible samples of 50? So you're going to take all possible samples of size 50 from the website, because that's where they're getting all this information, and then calculate the medians for each one of those. You'll take all those medians, and then you will build a distribution like this using the medians you get from those countless samples however many that would be. On the back page, it gives you the result of those bootstrapped medians, right? It kind of describes that very interesting process. We don't know what bootstraps are in the process, so this is kind of the first time you're introduced to that. Question 6 does that often, introducing you to a new concept, but it gives you enough information that you don't really need to understand how it works. What you can do is analyze the results. So here it says, you've got 15,000 medians conducted or created here. And what they want to do is we want to create or find what is the value of the 5th percentile and the 95th percentile. So if I take 0.05 times 15,000, it means the 750th person and then the 14,250th person in order would represent those percentiles. Remember that percentiles are calculated just like medians. Well, it's nice that they've got the medians in numerical order, and it tells me how many of each one of these were created using this method. So I can add these numbers up. What I'm looking for is, where does 750 fall? Obviously, they kind of make this pretty clear, is that once I get to this point, these don't add up to 750. So I will get to 750 somewhere in the 2,500 section. If I do the same thing but go backwards 750, I'll find that 95th percentile. And again, they're doing the same kind of thing. Once you get to here, you'll know you'll pass the 750th person. And so when I look at that result, that's the 95th percentile would be in the 2,950, so $2,950. So here you can see that I calculated those numbers and I used the frequencies here to find out where those positions lie. So that means that the 5th percentile is $2,500. The 95th percentile is $2,950. Part E goes in and says, okay, find the percentage of the bootstrap medians in the table that are equal to or between the values found in Part D. So since it said equal to or between, I went ahead, I said, I'm going to count up, not counting the 2,500, right, because that's equal to. So I'm going to take this number and add up all of these numbers and tell me how many that is, right? So when you do that, you'll find out there's 408 values less than 2,500. I'm going to do the same thing here. I'm not going to count the 2,950, but I am going to count all of the numbers from here all the way down to there. There's 188 values in that section. So when you combine the two of them and subtract them from 15,000, you have 14,404 different values that occur from 2,950 all the way back to 2,500. Okay, so quite a few of those values in between there. And if I want to know the percentage, well, the percentage would be the total amount divided by the total number of medians, period, which would give me about 96%, right? A little bit more. And again, you could have included the 2,500 and the 2,950 values, and I think you would still have gotten somewhere close to 96%. I think they adjust for both of those answers as correct. The last part would be using my range values here from this number to this number, and that being 96% in the middle. We're going to write a confidence interval and interpret that result. So it'll look like this. I'm 96% confident that the true median value for rent is between 2,500 and 2,950 on average. And that's the entirety of question 6 from the 2019 exam.